everyone, welcome if you're new, welcome back if you're not. My name is Talia. I'm a third year chem student at UCSD, and I make YouTube videos to help others studying chemistry. In this video, I'm going to be going into my unit on equilibrium and starting with an intro to what equilibrium is and Le Chatelier's principle. So if you need some review on those topics, keep on watching, and without further ado, let's get started. Okay, so my iPad is being a little finicky today, so I'm going to be sharing the slides on my computer and talking through them as we go through them. Also, don't mind the glare from the sun that's on my face, but let's get started. So the previous reactions I've talked about are all one-way chemical reactions. We start with reactants and we end with products, or we do the reverse. However, equilibrium introduces a new idea where we can have the forward and the reverse reaction happening at the same time at the same rate. And that is what equilibrium is. So I've given an example. One-way reaction would be something like sodium bromide plus calcium chloride yields sodium chloride and calcium bromide. But like I showed in the following example, we can show equilibrium with the double-sided with two arrows, one going in each direction, to show a reversible or equilibrium reaction. So I have the same reaction, but that arrow symbol means that the forward and reverse reaction are happening at the same time. And if you look at the graph I put on the slide, you can see that in equilibrium, the concentration of the reactants and the products eventually plateau and make a constant ratio that we will learn about in my following video when we talk about the equilibrium constant K. So in summary, equilibrium just means when both the forward and the reverse reaction are happening at the same time and the same rate. So equilibrium reactions can be represented with multiple different double-sided arrows, as I showed in the second bullet point. And this kind of just summarizes what I said on the previous slide, that in equilibrium reactions, the forward and reverse reaction rates are the same. Sometimes we can add a stress to a reaction to move it out of equilibrium, and then it will reestablish equilibrium once again. And this is called Le Chatelier's principle, which is when an equilibrium is under stress. So word for word, the principle states that when a system at equilibrium is subjected to a change, then processes occur to counteract that change and a new state of equilibrium is reached. So in other words, that means if we do something like change the concentration of a chemical, add heat, take away heat, increase pressure, decrease pressure, that pushes the system outside of equilibrium, but the reaction or the system will do something to counteract that change so the reaction can go back into equilibrium. And so on the next slide, we're going to talk about the different stresses you can have and how that will change the shift of your reaction to reestablish the equilibrium. So we have three different stresses and in each stress, there are two different ways we can go, either more or less, and the reaction will shift differently based on that. So we're going to start with temperature change. So the first stress we can put our system under is increasing temperature. And we've seen how in reactions we have heat terms either as reactants or products, meaning a reaction is either endo or exothermic. So if we increase temperature, the reaction is going to shift away from the side with the heat term. And then the reverse will happen if we decrease temperature. The reaction will shift towards the side with the heat term. Our next change is pressure and volume change. And these two variables are interrelated, as we learned in gases with, I forgot exactly whose gas law it was, but P1 V1 equals P2 V2. So if we increase pressure, that means we are decreasing the volume because these variables are inversely proportional. And we are going to shift towards the side of the reaction that has less moles. And for that, you're going to look at the stoichiometric coefficients. And if we think about it, like if we put all the moles of our molecules into a box and we shrink the size of the box, it's obviously going to be more favorable for the reaction to have less stuff in it so it can fit inside that box. And therefore, the reaction will counteract our shrinkage by shifting towards the side with less moles of chemicals. And the reverse happens if we apply the reverse stress. So if we decrease pressure, which increases volume or increases the size of our figurative box, then we shift towards the side with more moles. And if we think about it, if we give our reaction more space to happen, it's going to shift towards the side with more stuff to fill that space. And our last stress is concentration change. So if we increase concentration of a chemical, whether that be a reactant or a product, the reaction is going to shift away from that chemical, kind of similar to the temperature change, where if we increase heat, our reaction is going to go the other way and counteract it. And if we decrease the concentration of a chemical, the reaction will shift towards that chemical to make more of it to counteract the amount we took away. Okay, so now we're going to do some practice. So the way you might see Le Chatelier problems is you'll be given a reaction and given some stresses and be told what direction the reaction will shift, but also you can be asked another question, such as what's going to happen to the concentration of this chemical, which is what I asked here. Or if one of your reactants has a color and one of your products has a color, you might be asked, based on this stress and shift, what is going to happen to the color of our reaction vessel? Like, what color is the reaction going to be? So we have this reaction, 2SO2 plus O2 yields 2SO3 and heat, and its equilibrium. So our three stresses are increasing temperature, decreasing the concentration of SO2, and increasing pressure. So take a moment to try this on your own. Figure out the shift. So which direction will the equilibrium shift, left or right, and what will happen to the concentration of SO3? All right, let's do it. So first, if we increase temperature, we have our heat is on the right side, which means that this is an exothermic reaction. So if we increase the temperature, we're going to shift away from our heat term towards the left side. And as a result, we're going to be moving away from SO3 and decreasing our concentration of SO3. If we decrease concentration of SO2, we're going to move towards SO2 to counteract the decrease by making more and putting the system back into equilibrium. So we will once again shift left, which will also decrease the concentration of SO3. And finally, if we increase pressure, we are decreasing volume. So we want to shift towards the side with less moles. On the reactant side, we see that we have 2 moles of SO2 and 1 mole of O2. So we have a total of 3 moles. And on the product side, we have 2 moles of SO3. So the product side has less moles, and therefore we're going to shift right towards the products because now we have less space in the vessel that the reaction is happening. So it's going to be easier for less stuff to fit in it. And as a result, we're going to increase concentration of SO3. So that was the end of this video on equilibrium and Le Chatelier's principle. I hope that cleared up the concept a little bit for you. Feel free to leave any questions or comments in the comment section below, and I will do my best to answer them. In my next video, I'm going to be talking about calculating K, which is the equilibrium constant, and refers back to what I talked about in the beginning of this video with the concentrations of the reactants and the products plateauing once they're at equilibrium to reach a constant ratio. So if you need help with that, I hope you will join me back next time, and good luck with learning chemistry.